Good morning. Hopefully you've had a nice, pleasant night's sleep, tucked up in bed maybe at 9 p.m. because obviously you're eager to get started, bushy-tailed, bright-eyed for this morning's sessions. For today, we're going to kick off with a session from someone who generally actually spends much of their time designing data models for different teams in MongoDB. They've worked in technical services in the education team. They've delivered many courses, given many presentations, blogs as well to educate the entire community. And his favorite topic is data modeling, especially for MongoDB, which is a good thing because today's session is the principles of data modeling for MongoDB. Some say he is the data modeling equivalent of Neo from The Matrix, and that he sees the entire world as a giant schema. I couldn't possibly say whether that's true or not, but what I do know is he's one of our incredible data architects from MongoDB. I give you Daniel Kapal.
Thank you very much. I learned things about myself here, I guess, that I didn't know. Okay. Well, seems like we have a little issue. Maybe we'll do without that. Okay, let's get going without the clicker. That's the thing with the presentation at 9 o'clock. There's always something that you're not sure is going to work or not. Okay. Well, when I started working many years ago, there were two ways you could reach someone on the phone. You would either call them at home or you will call them at work. Now, I don't have a phone at work. How many of you still have a phone at work? It's not many, you know. Now, everyone has a cell phone. We probably all also have a Skype account. We have a Zoom account. We have a WhatsApp account. And we have whatever is going to be new next month account. So if this is a good change for all of us, well, it's a little bit less if you're a data architect and you end up designing a lot of these models over the years, where the only two modes of communication we knew of end up being columns in the table. So we have the work phone number and the home phone number. So welcome to this presentation on the principle of data modeling with MongoDB. So we're going to talk a lot about different aspects of MongoDB modeling, but we can also address the problem that I just highlighted there. We're going to talk about how we can migrate out of that situation when our schema needs changes. So we're going to divide the presentation into three sections. In the first section, we're going to talk about the need to model for MongoDB. Then we're going to talk about a little flexible methodology that you can apply. So that's going to be our techniques to model for MongoDB. And finally, we're going to spend a little bit more time on that third phase of that model, talking about schema design pattern. There's one in particular that I like a lot. That's my favorite one, the schema versioning. And that's what's going to help us basically migrate our schemas. So we have a lot to talk about, so let's get going. So our first principle is we model because we need to face and answer constraint. If there were no constraint, we would need to model. And what are constraints? What are we talking about? Well, there's physical constraint. Your network doesn't have an infinite speed. You also have some hardware constraints. We know that hard disks are cheap, but they're also slow. So you can use RAM, much faster, but much more expensive. So there's kind of the trade-off that you need to make there. You can also have software constraints, and these are the ones that we're going to pay more attention to today. Software constraint would be constraint that the software you're using are imposing on you. For example, you're using MongoDB. Well, MongoDB imposes some constraint on you. One is the size, the maximum size for a document. Other ones may be features that don't exist yet that may exist in the future. Especially if you think about that, many years ago, there were features we didn't have that now we have. So you would have done a model in those years. You could redo the same model but differently with these new features. So if we look at a stack of an application, we have the application that talks to MongoDB, that talks to whatever layer we have. Could be the cloud, could be just a physical machine. And those features, those constraints are going to map to some of those layers. So what's important from that previous stack? It's imperative to know the features of the products we use. So going back to that stack, when I joined MongoDB, there were some features in MongoDB that were already there. The document model has always been there. Indexes, sharding came up pretty early. Those are kind of table stacks thing. They're there. People were using them. You design with them. But there's a lot of things that appear since I joined. Things like transaction, field level encryption, data federation, archives. And having those in the product now will get you to model differently. For example, before we had transaction, you may have read one of our blog where we explain how you can do a transaction in MongoDB. And for those of you who are familiar with that, you can do a double commit. So that requires you to add few fields in your model, but there's a lot of things you'll be also adding in your code. So complexity is much more complex. After transaction, well, the code looks pretty much like what you're using in SQL. We use the same construct, etc. Field level encryption, for those of you who are not familiar with that, what we do is we can basically encrypt some fields and make it very easy to do things like GDPR, where the user has the right to be forgotten by just shredding the key. You can do that without a feature, but it's difficult. You will model it differently. Once the feature is available in your product, then you will probably have a different model. And the list goes on. One of my favorite one is the archive, what we introduced in Atlas quite recently. In the past, if you add a piece of data that after a certain point, you wanted to put it somewhere else, it's not something you need to keep hot. Maybe for the first 2 years, you're going to access it very often, but then after that, you want to put it in place that's going to be cheaper. Well, you would have modeled that with 2 collections a few years ago. But now, with Atlas functionality, you can just mark it with a timestamp, and you can use the archive. And these documents automatically will go into your less expensive storage area. Another feature that we're really proud of is Atlas Search. We had a lot of customers in the past that will either use regex in order to satisfy this requirement, or will use another system that, like Elasticsearch, that does a better job at indexing your searches. But now, search is for first-class citizen in MongoDB Atlas, and you don't need that anymore. So to illustrate the rest of the presentation, we'll build a little system. So we're going to create a social network for chefs, and we're going to have articles. We're going to take these articles, we're going to put them in category and tags, and we're going to let our users comment on them. If we had to model that in a relational model, it looks pretty much like that. We would have people write articles, write comments, and tags and categories that are put there with the relationship, one to many, many to many for information on the articles. The interesting thing about that model is if I give this problem to all of you here, most of you will arrive exactly at the same solution. Because when we model under relational tabular mode, to respect the third normal form, there's no two solution. Now, if you want to do denormalization, yeah, we may get some differences. But the third normal form, there is only one solution, and that's it. So it's kind of very easy to model it. If I give you the same problem to model MongoDB, some people may come with a solution where there's only one collection, the article in which we embed everything. Or, hey, I may not like that solution because my many-to-many relationship between my people and my article, I say, well, I'm going to get duplication here. If I change the information about one of my people, I'll have to change it in many places. I don't want to do that. So someone may say, well, I prefer a model where the people are going to be out, the article is going to carry the rest of the information. So the point is there's more than one solution possible, and they're both good models in MongoDB. So the only way you can get to the right solution is the optimal grouping of those objects into collection is determined by your workload. So what we're saying here is like you need to think about your workload first when you're going to model with MongoDB. So we're going to introduce this. This brings us to our second phase. We're going to introduce a simple methodology, flexible, 3 phases. We're going to take care of our workload first. After that, we're going to take care of our relationships. And then for optimization purpose, we're going to apply patterns if we need them. And what's interesting with that order of doing the things, it's a little bit different from what some people may use when they model for a relational database. Again, a relational database, we're used to go in a room with our colleagues, go to the board, draw the ER diagram, and then we go back to our desk, start writing the code. We may do optimization later, denormalize, whatever. But it's kind of the flow. And in MongoDB, basically what we were just saying here is you need to understand your workload first, and after you're going to be doing your data model. That's in MongoDB, but it applies to any NoSQL database. And the main reason is usually a lot of the solution we're trying to build with NoSQL, performance is a top requirement, and it's extremely important. And that's often the reason why people decided to switch from a relational database to NoSQL, is because you get much better performance. So let's going back to our methodology. First thing, we think about the workload. We're going to size the data. We're going to quantify all the operation, or at least the most important ones that we want to have on our system. And then we're going to also qualify them. There's other aspects of how important this one is, the security aspect of the query. Here's a little example with our project. For example, let's say there's 2 main writes that we identify for our system. We're going to be writing the new articles or updates, and we're going to write comments. So we don't get that many articles per day, maybe 10 per day. We get a lot more comments, maybe 10,000. And then on the read side, our users are reading our articles and the comments and all that, and we may have an analytics team also that's going to be reading everything to do some queries. So the important thing is really to list things, at least be able to identify the most important one. If you don't list all of them, I will say it's okay. Most of our customers, when we look at what they're doing, 1 or 2 queries will really drive the model. So you really want to understand those. For example, in this case, for performance, it's obvious that reading an article is going to be so much more important. Once you know those, and again, you may just know them in your head by working on your project without having to list everything. But I really like writing things down, all the assumption, because if something changed in the future, one of my assumptions is wrong, at least I have a base to go back that it was not 10 million per day, now it's 50 million, and that may have an impact on my model. So I take those most important ones, and then I'm going to add more information on it. You can add latency, you really want to get the size of the big object, and then things like we talked earlier, I want to think about the data lifetime for that piece of data, can use MongoDB, the archive, Atlas archive for that, and put my data into the colder storage once I don't need it anymore. And again, maybe I have security issues and all that. The point is, listing everything in your assumption will make it much more easy to make modification. So that brings us to the next principle, We can best act on new hypotheses if we know the original hypothesis. If you don't know where you were, it's difficult to know where you are now, okay? Coming back to our model, the second part of it would be to establish the relationships. We want to identify them. We're going to quantify them. And then that's a little bit different from SQL modeling, if you think about it. Because we're in the world of big data. A relation one-to-many, that's what we're used to, kind of made sense at that time. But in the world of big data, many may be 10, 1,000, 1,000,000. If you have 1,000,000 on one side to one object, you have to think about this thing a different way, And finally, the last step in the relationship is to identify if you're going to embed or reference the different entities, the different piece of information. And that's probably the most important question you have to answer when you do your model with MongoDB. And to illustrate a little bit how a relationship works in MongoDB versus a tabular relational database, if I had a car and I wanted to model it in a relational database, I'll probably take the wheels, put them in a table. I'll take the brakes, put them in another table. I'll put the seats, put them in another table. And when I want to use the car, I will reassemble the thing and get my car back. With MongoDB, when the car arrives, I take the car and I put it in the garage. When I want to use it, I get it out. Okay, we do only one read on the disk to get everything we need together. So the principle here is what is used together in the application is stored together in the database. So let's get you some rules to help you decide if you should reference or you should embed. But before we do that, just want to be sure it's clear that I'm not confusing anyone. When we talk about referencing, we start with two tables that's on the relational side. And in MongoDB, we'll create two parallel collections. That's what we say we refer to as either referencing or linking. Versus embedding, where my two tables become one collection. And the way it's done is the one that gets inside is often an array. You have a relation one-to-many, they will come together. So the array is the expression of a one-to-many relationship, basically, in the document model. That's what it means. And you can also see the little the numbers I put next to my array. That helps me understand how big this thing can become. In that case, I say the comments, I can have 0 comments from my article, I can get up to 10,000 or 1,000. So I want to max it at 1,000. I know I'm going to have issue if it's more than 1,000, so I'll decide what I do. But someone who's reading that understands basically the limit of what we're going to be putting in. So let's get some rules. And again, it's all based on what I want to use together, stay together. So if I have one piece of information, on this side I have a lot that are related to this guy, that may become too big to put in one. So it's pretty better to keep them separate. So we're going to reference. If I don't want to have to update many documents on a many-to-many relationship, because many-to-many, something will be duplicated. In that case, it's pretty better that I keep things separate. Okay? And if I have a piece of information that is linked to a lot of stuff there, but there's really a subset that I need. I have a product, and I have 1,000 reviews on it, but I really need the top 20 reviews most of the time. You probably want to keep these things separated. On the opposite, on the other side. And again, we're really talking about how you would model with the document model. MongoDB supports transactions, but you should always prefer the document to the transaction. It's much more performant. It's much easier. Okay? With the document, you get everything you get in the transaction. It's ACID, it's atomic, you read the document, you write the document, you get all the security there. Integrity of read operation, read the document, I get everything related to it. All the other tables that were linked, they're inside one read, get everything. All the relationship of one-to-one, one-to-many things are inside. If I need to write to many tables, when you write to one document, you write to different sections, but it's one write, atomic again. I have pieces of data that after a while I want to put in a colder storage. I have invoice. The invoice I have list of products. I have an address and all that. Relational model, I would have a ton of collection. If my MongoDB, I model that with a lot of collection, it's harder to just say, take just the invoice from 2 years ago, let's move them somewhere. So I will say, when you want to delete piece of data that's related, or you want to archive, keep them together. And my favorite rule, by default, okay? Prefer embedding to referencing. I prefer simplicity over complexity. And embedding will get you a simpler model. It usually matches what you have in your code. That's what you want, and that's what our developers like, you know? You just take the object that they have in our classes and just drop them. So that's what's going to look like. Okay, so that brings us to the third phase of our model, which is identifying patterns and applying them. What are patterns? First, who has read this software engineering classic by Eric Gama and friends? You know, what was great about that, it's not just what they put in terms of patterns, but it's really creating this language that we could share with our teammates. I would go in a room, and I would talk about a facet, I would talk about an observer, and people will know. I wouldn't have to say I'm putting this here and there and there, you know. So that's what we're trying to do also here, you know, with our patterns in MongoDB. So we came out with a list of 12 patterns across what we think are the most used case to characterize different applications that our customers are writing. And I put little check mark to identify the one that are the most likely for each use case. So we don't have a ton of time today, so we'll talk about the schema versioning, which is my favorite pattern. And that brings us to the third part of our presentation, where we're going to evolve the schema that we saw at the beginning using the schema versioning pattern. So any successful system that you have will go through change, okay? Including and likely changing the data model. So that's not if, it's more when. And changes could be modifying a field, modifying a relationship. Okay? Obviously, that's simple simplification we do here. It could be changing like X relationship at once, and that is a lot more complex, but it's still the same thing. It could be a new feature exists in MongoDB. I want to remodel now because I want to take and make usage of that new functionality without whatever code I've written and all that to make it more complicated. So let's take our little example here. I have some chef, they had a home phone number, work phone number, and now I have a new class of chef that I'm going to be adding to my system. Alton Brown, a little bit more modern, not just as is these two phones, but he also has a Skype number that he always prefer using. So we decided that we're going to change our database to go from that version 1 to a version 2, where we break up the relationship now. Those two columns are gone. We're going to create something that's more, a little bit more flexible. So that migration, basically, in the relational world will look a little bit like that. On Friday night, we would have version 1. We will bring the system down. We will migrate all our data from one table into 2 tables, and then we would reopen the system. And if we try to do the same thing with MongoDB, so we have our new user here, we have Alton with this information, that's what we want to have. So we're going to create this little array inside our document in which we're going to have a more flexible mode work, and we can just list the mode and the number that's associated to it. But the whole magic here of that pattern appears in that piece of information, the version. When you deal with a relational model, you have version 1 for your schema, version 2 for the schema. With MongoDB, we're going to piggyback on polymorphism. Polymorphism let us have different shape of documents in the same collection. So we're going to put the version number in every single document. And that's going to look like that. I'm going to have 3 documents that I want to migrate to that on my Friday to my Monday. So I'm going to migrate sequentially my documents. Now, if my application is able to read the documents in a different shape, I don't have to bring the system down. So what I need to do first is go in my application, be able to either recognize the shape or use a version number, do the appropriate read, reformat the thing, and then send it to the application that's going to do business logic with it. But I'm master of my migration. I can take as much time as I want to migrate my documents. I cannot migrate all of them if I want, as long as my application is able to handle the different version. So MongoDB not just lets you develop and deploy quickly your application, but also lets you evolve your application and your schema quickly and cleanly. And I think it's a huge asset. So our presentation has 3 sections. I want to talk about the need to model. Got 2 principles out of that. So it's imperative to know the features of the product you're using. Need to invest a little bit in that. The optimal grouping of your object collection is really determined by the workload. So you really need to think about your workload at the beginning, at least the most important queries. Technique for modeling, we describe a very simple methodology in 3 phases. What I like about it is writing things down so you'll be able to act on the new hypothesis because you know where you were. And then you need to answer the question, are you going to link or reference the information that you have? And for that, the main thing you need to remember is like what is used together in the application should be stored together in the database. And finally, any successful system will go through changes, likely including data model change. So MongoDB lets you develop and deploy quickly, and also evolve your application and the schema quickly. So obviously, we had 30 minutes. It is so short. I could talk about that for days. Love the subject. As a matter of fact, we did, because we have a bunch of resources that are much more extensive. There's a series of blogs that I wrote with other people over the years. So just search for my name. There's one on pattern. There's another one on anti-pattern. We have the MongoDB University. How many of you have taken classes at MongoDB University? That's not a lot. How many of you know that it's totally free? A little bit more. We're getting there. Okay. It is totally free. We want you to take classes. Our goal is not to make money out of university. Our goal is to ensure that you guys are doing the right thing. So our courses are there. Please go take them. So we have 2 main courses on data modeling. The extensive one is M320. And there's a shorter one, M100, MongoDB for SQL Pro, which is about an hour and a half, 2 hours, no homework. Okay, M320 has homeworks, and you're going to work. But the second one is very short, listen to it, and it's going to do a full mapping of what you know if you're coming from the relational world to MongoDB. And that's what we want you to feel comfortable that everything you've invested maybe in other technology before, it's not lost, it's just a mapping. At the end, it's still a database. There's concepts still apply. And finally, if this is not enough, we do have professional services. We have the team. These guys are absolutely incredible. I will say they're probably the most knowledgeable people we have in the organization. So we can have someone who go to your site, do some training, help you with your model, etc. And the thing is, when you're getting one of these guys, you're not just getting one, you're getting the team. Because if that person is not as savvy on some little aspect of security or whatever it is, the whole team is behind and can help them. So again, they're great. If you have no big project, your first project with MongoDB, I would strongly suggest that you make use of them. And here's some code if you want to go to some of those blogs in the university. And that's about it.